In this video, I'll demonstrate how to create a transit gateway and how to attach VPCs to it. Okay, so here you can see we're at the VPC dashboard in our AWS console. And near the bottom here on the left, we're going to go to Transit Gateways. And we are going to create a new transit gateway. I'm just going to call it Rick Demo TGW. And I'm also going to make that my description here. And I'm not going to set up any of the BGP stuff here. I'm just going to accept the default BGP configurations, but just understand that BGP support is possible with the transit gateway. And so the purpose of this is if we are connecting to an on-premises network using a VPN or using Direct Connect, AWS can use BGP to communicate with your routers in your data center and exchange route table updates automatically. So this allows the transit gateway and your on-premises network to share routes and advertise routes back and forth between each other. And this will help to keep a dynamically built route table just in case some link goes down or traffic needs to be shifted differently. And it also ensures that your on-premises network knows how to reach these AWS VPCs. Now, in this situation, we're just going to use the transit gateway to connect multiple VPCs. So I really don't have to worry too much about the BGP piece of this thing. So I'm just going to skip that. I'm also going to skip setting up the transit gateway CIDR blocks. Again, this is not necessary if we're doing VPC to VPC routing, but it can be useful if we need the transit gateway itself to have its own IP space. So to do things like GRE tunnels or to work with SD-WAN appliances, we might need to use this. And some of these other settings here, we are going to leave DNS support enabled. This allows DNS traffic to flow across the transit gateway and allows one VPC to resolve DNS names in another VPC. So we're going to go ahead and leave that enabled. Security group referencing support will allow us to reference security groups across multiple VPCs. So for example, an EC2 instance in VPC A could use a security group that is present in a different VPC. It could reference that other security group in security group rules. We're going to just leave that alone. ECMP support, equal cost multipathing, allows multiple tunnels at the same time, multiple VPN tunnels. Basically, this is something that'll improve VPN throughput. We can just leave this as it sits. Same thing with default route table association and default route table propagation. We are not going to change those either. So what these mean is that when you attach a new VPC to this transit gateway, the default route table association means that that new attachment will automatically get associated with the default route table of the transit gateway. So every new attachment will automatically use the default transit gateway route table. And if propagation is enabled, this is going to control whether new attachments will automatically propagate their routes into the default transit gateway route table. So because we're leaving this enabled, when I attach a new VPC to the transit gateway will automatically learn about the CIDR blocks of those new attachments and add them to the route tables. So I know I spent quite a bit of time on these options. We're not changing any of them. We're just going to leave them all exactly as configured, and we're going to click Create Transit Gateway. And so now I've got my transit gateway all created and ready to go. It's time to start creating some attachments. And at the moment, I have two VPCs configured in this region, in this AWS account. So I'm going to go to Transit Gateway Attachments. I'm going to create a new attachment. And I'm going to give a name to the attachment. And I'm just going to call this first attachment RIC demo TGW attach. So I'm going to attach my RIC demo VPC to my new transit gateway. And under transit gateway ID, I'll select my RIC demo TGW, my transit gateway. This is going to be a VPC attachment. I'm going to stick with all of the other default settings, and I'm just going to select my RIC demo VPC here. And I'm going to select the subnets in which to create the transit VPC attachment. I've only got one subnet here in US West 2A. I've got my public subnet, and I've also got my private subnet. So I can pick which subnets in which to create the transit VPC attachment. I'm going to choose my public subnet here, and then I'm just going to go ahead and create the transit gateway attachment. And I'm going to go through the same process in my other VPC. I'm just going to call this attachment peer VPC TGW attach. I'm going to attach it to my transit gateway. And again, I'm just going to select a VPC. I'll pick my peer VPC here, and I'll pick the public subnet in my peer VPC. Then I'll create that transit gateway attachment. So now I have attached both of my VPCs to the transit gateway. So at this point, here's what my network diagram looks like. I've got public subnets in each of my availability zones, and I have created an attachment from each of those public subnets to this transit gateway. And so now, kind of like we saw with VPC peering connections, I have established a connection between these two VPCs. What I have not done yet is update my route tables. I haven't told my route tables how to use this transit gateway to get traffic to these destination networks. So let's go back to our route tables here. And I'm going to start with the public IGW route table. Let's come over here to routes and let's see what we have. Right now, all we have is a default route for the internet gateway and our local route. So we're going to need to change that. I'm going to add a new route to tell me how to get to the 10.2.101.0/24 network. And very similar to what we did with VPC peering, we are going to point this route at a transit gateway. So very similar to pointing it to a peering connection, we're going to say if there is traffic destined for the 10.2.101 network, send it to a transit gateway, and here's the transit gateway ID. We're going to have to set up these route table entries for both of the VPCs. So if I go back to my route tables, I've got to find the route table for the peer VPC. I've got to go to routes there. I've got to edit my routes, and I've also got to add a route there for the 10.1.101.0/24 network, or I could even go less specific here. I could say for the 10.1.0.0/16, I could create a route table entry that would allow routing traffic in both my public and my private subnet. I'm going to route that traffic to the transit gateway. I'll pick my transit gateway here, and I'll save those changes. All right, so now we've got a transit gateway created. We've got both of our VPCs attached to it, and we've updated the route table entries as necessary. And one last thing I want to show you. So here under transit gateways, I've gone to the transit gateways route tables. And we are looking at the route table entries here for the transit gateway itself. And I just wanted to show you, notice it's got routes for both of these VPCs. So if you've ever configured a router that has directly connected networks, and it automatically knows about those directly connected networks, it's kind of like what we're seeing here. It is adding route table entries within the transit gateway so that it knows how to get to all of the VPCs that it's connected to. Each of these VPCs have a separate transit gateway attachment ID. So that's how the transit gateway knows how to route that traffic. All right, so the very last thing I'm going to do here is I'm just going to select my transit gateway. I'm going to go to actions and I'm going to delete it. And it's not going to let me do that. I'm going to have to delete my transit gateway attachments first. So let's go ahead and get rid of those. It's always a good idea when you're done with just about anything to just clean up as you go in the AWS console. That way you don't run the risk of just kind of leaving something hanging around that's going to add to your bill, or leaving something in there that's going to create confusion later on, right? Both of those things are bad things. So I try to stay in the habit of deleting everything. Once I'm done with it, I get rid of it. Okay, so now my transit gateway attachments are done being deleted. I'm going to come back here, and once more I'm going to try to delete my transit gateway. Let's go ahead and get rid of that. Now the transit gateway is being deleted. And when you're completely done with that deletion, you may want to go back and double check your route tables. Because what you may find, if you go to the route tables and you look at your routes, you're going to see a black hole. This is a route to a transit gateway attachment that no longer exists. So unlike VPC peering connections, when I delete them, they will automatically get rid of the associated route table entries. With transit gateway attachments, I have to go into my route tables and actually remove the routes that reference those transit gateway attachments that I've deleted. So you're going to have to go back into both of these route tables, edit your routes, and get rid of any route table entries that reference those transit gateway attachments.